Crumple zones are areas of vehicle that are designed to deform and crumple in a collision. They are also present at both ends of the cars in order to minimize damage on the occupants. Crumple zones mainly accomplish two safety goals. They reduce the initial force of the crash, and they redistribute the force before it reaches the vehicle's occupants. They reduce the initial force of the crash using a large surface area, and so when the other vehicle impacts the car with the crumple zones, it is possible to see how all the zones, whether in front or back, would just get squashed, and this is because of as the surface area increases, the pressure applied would decrease, resulting in an equal distribution of the force or pressure applied. When the collision occurs, a large amount of force is applied in a short amount of time on the occupants of the car. Crumple zones allow that force to be distributed over a larger surface area, and so it takes a greater amount of time for the collision to reach the occupants. Since it takes a large amount of the total force to reach the occupants and go through the crumple zones, only a fraction of the force would be left, and would cause less significant damage to the occupants. Because crumple zones distribute the force, they also distribute energy, and so the kinetic energy of the car would be converted from kinetic energy into thermal or internal energy.
Airbags is a safety feature in the vehicle which is designed to inflate suddenly the moment a collision occurs, and then it starts deflating slowly afterwards. The airbags nowadays started detecting the presence, the seat position, and the weight of the passenger in order to inflate the bag in a manner that minimizes severe injuries and casualties. During the collision, the kinetic energy of the passenger is reduced when the passenger becomes in contact with the airbag. Kinetic energy is transferred into internal or heat energy. According to the kinetic energy equation, kinetic energy is equal to half mass velocity squared. Thus, if the velocity of the passenger is decreased, so will its momentum, because momentum is mass times velocity. Also because it's an inelastic collision which would cause some loss in kinetic energy. And moreover, the impulse would decrease as well because the force takes more time in order to change. Hence, the approximate chances for severe injury or even death is minimized due to the conversion of kinetic energy to heat energy and the decrease in both impulse and momentum.